Hey guys, Mr. Wiz here. Welcome back to my channel. If this is your first time on this channel, we build video games here and we have a lot of fun doing it. But this is probably not the best video to introduce you to. So I have a playlist with a bunch of lessons that we did before this one. I would recommend you go check those out and then come on back to learn more. So this week we have been working on physics. We've been looking at, in the last video, we looked at velocity, and we looked at acceleration as our two big ideas in the last video. So just a quick recap on what we were talking about. These were the formulas from the last video. We talked about how velocity is basically a change in distance over a change in time. That little triangle you see there is the delta symbol. It represents change. So we said that velocity is a change in distance over time. Basically, it's the same thing as speed with the slight difference that it also factors in direction, right? So velocity is speed plus direction, and it's a change of distance over time. Acceleration is a change of velocity over time. That was the big idea in the last video. So today we're going to focus more closely on acceleration. One acceleration in particular, a very common form of acceleration that affects you every single moment of every single day. In fact, you're being affected by it right now, even if you don't realize it. That form of acceleration is gravity. Yes, gravity is acceleration. If you don't believe me, here's what I need you to think about. When an object falls, how hard does it hit the floor? Well, you need more information, don't you? Because if an object falls only a short distance, it's not going to hit the floor very hard. But if it falls a farther distance, it hits the floor very hard. Why is that? Because of acceleration. Acceleration is a change of velocity over time. What happens, the way gravity works, is the more time you spend falling, the faster you fall. Because acceleration is a change of speed, a change of velocity. The longer you're falling, the faster you're falling. In fact, the number, if you're curious, the number is 9.8 meters per second squared. Or, if you prefer in feet, it is 32 feet per second squared. So what does that mean? That means if you're falling for exactly 1 second, the speed that you're moving is now 32 feet per second. If you're falling for 2 seconds, you're now going 64 feet per second. If you're falling for 3 seconds, you got to do another one. That's 96 feet per second that you're now moving at. So the longer you're falling, the faster you're falling. That's why if you fall only a short distance, it doesn't hurt very much. But if you're falling a much further distance, you can hurt yourself very, very badly. Yes, gravity is a form of acceleration. It is a common form of acceleration that we use every single day, which is also why we use it quite frequently in video games. So today we're going to be using gravity in the games that we are about to build. So let's get started. I went ahead and created the first couple blocks for us. You're welcome to pause this video and copy this if you want to. So basically what I have here is I just grabbed a beige or tan background color. I grabbed a dinosaur and I moved him to the bottom left corner of the screen. What we're going to do is we're going to create a program where this dinosaur can jump and he will also throw a basketball. So we're creating a little basketball throwing program. I originally decided to call it shooting hoops, but now I think I'm going to change the name. I'm going to call it Dino Ball. That just sounds more fun. Okay, so to do this correctly, to do this accurately, we need this game to have gravity because if the player is going to jump, we need him to come back down. And if he's going to throw a ball up in the air, well, where do we need that ball to come? We need that ball to come back down as well. And we want it to move in a way that is realistic. So that's where we're going to use gravity. And in this situation, we're going to code gravity as acceleration. So let's go ahead and get started. All right, so first thing I want to do is I'm going to go ahead and code the jumping of the character. So I want the character to jump when I press the A button. So I'm going to go ahead and go to controller, on A button press. So jumping means that he's moving up, and he's going to move up with a speed. He's giving himself momentum, energy, and speed. He's moving up, so that is velocity. Remember, velocity is speed and direction. Well, we have the direction's up, and we're going to give him a speed for that. So we are going to give him velocity in the y direction. So I'm going to grab a set. So set my sprite. I'm changing where it says x to velocity. It is in the y direction. Now, is this going to be positive or negative? Think about what we've been learning about with our x and y directions. If you're going up, is that going to be the positive y direction or the negative y direction? Keep in mind, this is not math class. We're talking about JavaScript here. So if you've been remembering, with JavaScript, it's a little bit different than you might expect. Up is the negative direction. Down is the positive direction. So we're going to have him jump up in the negative y direction. Now, what number we're going to put here is really up to you. The bigger the number, the more energy he's going to have, right? The faster he's going to jump, basically. So I'm going to give it a negative number since we want him to go up. And just get started with, let's just see what 10 looks like. So if I give him negative 10, I'm going to press A. He's now moving up. Okay, that's very slow. Also, he's not coming back down. Why is he not coming back down? He's just going up forever. He's not coming back down because we haven't given him gravity yet, right? We still need to do that. But let's go ahead and give him more speed. That was really slow. What about 50? Oh, yeah, that's good speed. He still needs to come back down, but that's a good speed. Okay, so I'll leave it at that. All right, so when I press the button, he jumps up with a speed of 50 in the negative y direction. So velocity y, negative 50. All right, now we need him to fall back down. We need him to have gravity. So I'm going to, in that same area where he jumps, I'm going to give him acceleration. So I'm going to set, I'm changing x to acceleration. So remember, we have two directions still, acceleration x and acceleration y. We're talking about gravity, which is pulling him down, right? So that is the y direction. So I'm going to give him acceleration y. And now I have to decide how strong to make gravity. So the strength that I make gravity will depend on how fast he falls, right? So it's really up to me, whatever I feel fits the game. What would happen if I give him 50? Let's see what that looks like. So he jumps up and he comes back down. That's actually not bad. Oh, and he falls through the floor. All right. Why do you think he fell through the floor? He jumps up, he falls, he keeps on falling, keeps on falling, keeps on falling. Well, technically there is no floor in this game. That's why he fell through it. So I need to give him something that makes it so he stops when he hits the bottom. So what I'm going to do is I'm going to grab an on-game update block. So the on-game update block is something that runs every frame, right? It's running constantly. So constantly while this game is running, I need it to check to see if he's standing on the floor, right? So we're going to imagine the bottom of the screen is the floor in this world. So I need him to stop moving when he hits the floor, when he hits the bottom of the screen. This is starting to sound a little bit like a logic situation. So what would be the condition that I'm looking at here? If something is true, I need him to stop moving, right? What needs to be true? What is the condition that we're going to put in this logic block? If, now I worded it as he hits the bottom of the screen, right? But from the coding perspective, what would that be equal to? Well, it's the bottom of the sprite basically touching the bottom of the screen. That's what we are worried about. So let's grab one of these equal blocks. And then we're going to go to sprite, and we're going to grab this bubble here. So this bubble, remember, allows you to grab values for the sprite's stats, basically. So if my sprite, and instead of doing x, because x measures the middle of the dinosaur, the middle of the sprite, I'm going to click on it, and I'm going to drag it down to the part that says, right here we have left, right, top, bottom. I want the bottom. If the bottom of the sprite, that's basically what this bubble is saying. So if the bottom of my sprite, which is the name of the dinosaur because I never changed it, if the bottom of my sprite is equal to, what's the position at the bottom of the screen? Do you remember? This is one of those numbers I told you early on. You need to make sure you're trying to remember. What is the value, the number of the bottom of the screen, that Y position, it is 120. So if the sprite's bottom, if the bottom of the sprite is equal to 120, we might even want to do greater than or equal to. If this bugs, I'm going to switch it to greater than or equal to. But let's just leave it at equal right now. All right, if the bottom of the sprite is equal to 120, I need the gravity to stop working. Because just like in our real life, if I fall and I hit the floor, guess what? I don't go through the floor, right? I stop. So even though gravity still exists, it's no longer pulling me down. I'm no longer falling, right? So what we're going to do for the sake of this game, to keep some realism here, I'm just going to duplicate this. So this acceleration block that's creating our gravity, I'm going to turn the gravity off. So I'm going to set it to 0. So once the dinosaur hits the bottom of the screen, he will stop accelerating down. He will stop speeding up as he falls. Let's see what this happens, or let's see what this looks like. He jumps, he falls. Oh, he still fell through the floor. Let me show that again. He jumps, he falls, he still fell through the floor. Look at the code for a second. Look at what's going on with the dinosaur. See if you can figure out why he still fell through the floor. All right, before I show you the answer to this, let's talk a little bit more about acceleration and gravity. I'm going to go back to my drawing tools here. So, when you jump up, or if you throw a ball up in the air, something like that, you are giving an object velocity, right? I'll represent the velocity as a v. So if I throw an object up in the air, I'm giving it velocity in that direction. The reason it doesn't go on forever and ever and ever and ever and ever is because of gravity, right? So if I throw something, let's say I have a baseball. I don't, but let's say I did. Let's say I had a baseball, and I threw the baseball up in the air. I throw it up in the air, I'm giving it velocity. So I'm giving it a speed and a direction. It's moving up in the air at whatever speed I threw it at, right? It leaves my hand going that speed in that direction. Gravity is pulling it down. Remember, gravity is a change of velocity. So as it goes up, the speed of the ball slows down. So it's left my hand at a certain speed, and then it starts to slow down, it starts to slow down, it starts to slow down, it starts to slow down. So from the drawing, if I can keep drawing this here, as the ball slows down, it eventually stops going up. So you end up at the crest, at the top of the curve. So it's flying up, 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 and as it's going up, the velocity is getting smaller. The speed is slowing down. I'm using smaller arrows here to represent that it's a smaller velocity, right? Eventually, at the very, very tippy, tippy top, the velocity equals 0. So gravity's pulling on that baseball. It goes up and up and up, and it slows down, and it keeps slowing down, and it keeps going, slowing down. And then at the very top, when it stops going up at all, the velocity of that baseball equals 0. Only for a moment, only for a split second, but it equals 0 because it's no longer going up. But remember, gravity's been pulling it down the whole time. So while this ball is going up, acceleration exists in the form of gravity, and acceleration is constantly trying to pull the ball down. And that's why it's slowing down. So it slows down, slows down, slows down. It gets to the very, very top. And then what happens? Velocity is equal to 0 for a split second, but gravity is still pulling it down. So what happens next after the ball reaches the very top of that curve? It starts to come back down. It starts to speed up. So after the ball gets to the very top of the curve, it comes back down. Oof, that was a bad drawing. Is there an undo button? There it is. I'm not a great artist. I'm trying to draw a decent curve here, though, for you guys. Okay. That's not bad. All right. So at the very top, velocity equals 0, and then it starts to fall back down. So the velocity starts to pick up. It starts slow, and it gets faster and faster because just like we talked about earlier in this video, gravity speeds things up as it falls. The longer you're falling, the faster you're falling. And that is true about everything. So here's a fun little fact for you. The starting V, the starting velocity, when the ball leaves my hand, the speed that it's going, and then the final velocity at the end, when it finally comes back down. How do those two speeds compare? Any guesses? How do those two speeds compare? Its starting velocity and its final velocity when it comes back down. Here's the interesting thing about it. As gravity pulled it down, it slowed the ball down, then it sped it back up. The speed the ball goes when it reaches the bottom of this curve is the same speed as when it first took off. The only difference is it's going a different direction. So they're opposite velocities. Pretty cool, huh? The speed that it falls when it hits the ground is the same speed as when it took off. They're just going in opposite directions. Because it added the same energy that it took away, basically, right? As it slowed down, it slowed down, it slowed down, and then it pulled it back down. So it ends up at the same speed. Pretty crazy stuff. So, going back to our program, I told the code that when my sprite, the bottom of my sprite hits the ground at 120, to stop the acceleration. So if the gravity suddenly stops when it hits the ground, great. But what didn't stop? The velocity. Because when it hits the bottom of my screen, it's moving the same speed as when it first took off. It's just moving the opposite direction. So when this dinosaur hits the bottom of the screen, he is, instead of moving -50, which is what he started, he's moving +50. So I need him to stop. So the same time that he hits the bottom and I turn off gravity, I need to turn off his speed as well. So I'm going to change his velocity in the y direction to 0. Because he was speeding up, I need him to stop. I need him to stop moving. So let's try it again. So he jumps, he comes back down. Oh, it didn't work. Did I do something wrong? I don't think I did anything wrong. All right, let's try this. I told you guys that it might bug out. Instead of doing =2, let's do greater than or equal to. There it is. Okay, so why did that make a difference? Simply because the computer sometimes misses it, right? =2 means it has to be exactly. So yes, there is a moment when the bottom of the sprite is exactly at 120, but if it's happening kind of fast, the computer might miss it. And if it gets to 121, 122, and it misses that 120, doesn't register it fast enough, it's not going to catch this, right? So sometimes when you have things like that, it's better to go with a greater than or equal to or less than or equal to than just equal to. It helps eliminate those bugs. All right, so now I have a dinosaur that jumps and everything looks good. The gravity is working correctly. Cool, cool, cool. This is working exactly the way that it should be working. Awesome. All right, so now for the second part, we want to give this dinosaur a basketball. We're going to have him throw a ball across the screen. I'm going to do this with a different button press. So we're going to use, instead of A button press, we're going to use B button press for the basketball. So that way the player can jump with one button and shoot with a different button. So when B button is pressed, he's going to throw a basketball. So what I'm going to do is I'm going to give him a projectile. So we're going to go to the sprite section. We're going to do the projectile from my sprite. We're going to give him a projectile like we've learned about in previous videos. So I don't think they have a basketball sprite in here. Doesn't look like it. Maybe I can grab something and edit it real quick here to look like a basketball. Oh, you know what? They got a little red ball. We'll just use that. If you feel artsy, feel free to design it and change it, but we're just going to use that for the purpose of this video. Okay, so he's going to shoot a basketball. We're going to shoot it kind of diagonal. So the numbers they have right now is 50-50. I want it to go this way. So I need to go to the positive x direction to the right and the negative y direction. Now, what speed I decide to give it is really up to me. We can leave it at 50 for now just to see what that looks like. Let's see what that looks like. So if I throw the ball, that's not bad. I kind of like that speed. All right, so the ball's flying and it's going off and it's going off forever and forever and forever and forever because that ball does not have gravity. We need to give it gravity just like we gave the player gravity. We need to give the ball gravity. So I'm going to go ahead and just copy the gravity block that I used for the player. And I'm going to put it in the ball, and I have to make sure I change the names here. So instead of saying my sprite, this should now say projectile. Now keep in mind, I can always change these names. All right, so now I throw it. Hey, look at that. It comes back down, just like it's supposed to. Now, if I jump and throw it, I can even do that and throw it from higher up. This isn't bad. I kind of like it. I kind of like it, guys. This is working out all right. And it's creating a realistic curve. Oh, math term for you. What do we call that curve? If you're looking at the curve of the basketball, as it flies up, it's similar to that curve that I drew a few minutes ago. There is a name for that curve. Anybody know it? We call that a parabola or a parabolic curve. That is a parabola. And that is what we see when we throw things because gravity is pulling it down. So as I threw it, we threw this ball with, here we can actually just look at it, 50-50, right? So we threw it, if I go back to my drawing board, we threw it with a speed of 50 pixels per second in the x direction, which is forward, and we threw it with a speed of 50 pixels per second up as well, right? So its diagonal speed is not really 50. The diagonal speed you'd have to calculate with Pythagorean's theorem. So you'd have to get 50 squared plus 50 squared and then take the square root of that, which I'm not going to do right now. But we're moving it to the right at 50 pixels per second, and we're moving it up at 50 pixels per second. At the end here, the end of the curve, it's falling down at 50 pixels per second. Did the speed going to the right change at all? So it goes up at 50, and then at the end, it comes down at 50. Did the speed going to the right change at all? It absolutely did not, because gravity doesn't affect the x direction. Gravity only affects the y direction. So it's still going 50 to the right. The only thing that changed was the up-down velocity, right? 50 up, and now at the end, it's at 50 down. And of course, up at the very top, it's at 0. So our math is mathing. It is checking out. It is doing what it is supposed to be doing. Great. All right. So this is not bad. Now, feel free for your own program to change these numbers. If you want your character to jump higher, you might want to make it a higher VY. If you want them to throw the basketball more, you can change these numbers, right? The only thing I would have to say to keep your game realistic is make sure the gravity is the same for both objects. That's important. The gravity for the player and the gravity for the ball should be the same number. So if you don't want to use 50, if you want to use a different number, feel free to change it, but make sure they both have the same number. Why is that important? Because the player and the basketball are both on the same planet. Gravity affects everything on the planet the same way. Regardless of your size or shape, gravity affects us all the same way, okay? So if they have different gravities, if the player has one gravity and the ball has another gravity, it's not going to feel very realistic. It's not going to work very well for your game. So make sure they both have the same gravity. The other numbers you can change for the velocities, but make sure they both have the same gravity. If you don't want 50 and you want to go something else, that's absolutely fine, but make sure they match. All right. Let's do one more thing. This is probably a fine place to stop the video, but if you want to get just a little bit extra, I like to make my games realistic. So let's do one more thing to make it just a little bit more realistic. The Vy of our basketball right now is 50. So when I shoot it, it shoots up at 50 pixels per second. And when I jump, I'm also jumping up at 50 pixels per second at the very beginning, right? Here's the interesting thing, though. If I throw the basketball while I'm jumping, if I'm jumping up in the air and I throw the basketball, shouldn't my momentum add to the momentum of the ball? If I'm jumping up as I throw the ball, if I'm moving up in the air as I throw the ball, shouldn't it have that energy, that speed that I give it? Shouldn't that be added to the ball? So let's do a little bit of addition to make our game just a little bit more realistic. You ready? All right. So the Vy, right now we have it at -50, and that's fine. Of course, like I said, you can change that number if you want to something else. What I'm going to do, though, is I'm going to put some math in there. So for my Vy for my basketball, it's still going to be -50. So I'm still throwing it with the speed of -50, but I'm adding to that ball my speed, my velocity. So to do that, I'm going to go to sprites, and I'm going to grab that bubble block. Remember, that bubble allows us to grab data from the sprites. And so the -50 is now adding my sprites Vy. So now the basketball's speed will be 50 plus my speed. And since we're both should be moving the same direction, that should add energy if I shoot while jumping. So let's try this out. I'm going to press A or spacebar to jump, and then enter will shoot, or I can use X on my keyboard to shoot. So that's just shooting if I'm standing. If I jump and shoot, oh, look at how much more energy I gave that. That looks pretty realistic, doesn't it? I have kind of a weak throw if I'm just standing, or if I jump and shoot, it goes real high because it added the energy of the player. That's pretty cool. I like that. Okay, so this is where I'm going to stop the video. Feel free to turn your program into a game. This would be a great place to add another sprite. You could add a basketball hoop and maybe get points whenever the ball hits the hoop, right? That would be a great way to play this game. You could even make it more challenging by maybe having the goal, the hoop, maybe have it move. So now you have a moving target as well. That would be kind of a fun twist to this game. But I'll go ahead and stop it now. I hope you learned something new from this when we're talking about gravity. This is going to be really helpful for you going forward in your games, because having gravity in your game is a great way to add realism and really improve the quality of your gameplay. So if you learned something new in this video, please click that like button. If you are not already following us, please go ahead and do that. And don't forget to share your programs with me. If you decided to turn this into a game, I want to see it. So if you decide to turn this into a game, click that share button, name your game, share the project, copy the link, put it in the comments. I want to see your games. All right. Until next time, thanks for following. Thanks for watching. I hope you have a great rest of your day.